Okay, are we live? Hello, hello, welcome. So, let me take a moment before we get started. Yeah, I guess I'll just keep plugging away here. I like solving these problems, man. I don't know why. I just enjoy it, I guess. I don't know about anything anymore. I'm all over the place. When it comes to the future. Um, Praise God, we have Christ, man, and we have the good news, and that's all we need. Everything else is like, who knows? But anyway, I don't know. I kind of feel like it would be interesting to finish all these problems and then think about what I want to do next. I guess something like that. I do have things I probably should take care of, like other things in my life, but for now we'll just keep going here for today. Maybe tomorrow I'll work on some things. Given string num representing a non-negative integer num and an integer k, return the smallest positive integer after removing k digits from num. This is not what I was expecting. This is not what I was expecting. Okay. I thought this was going to be an entirely different question. This is not the question I was expecting. That's interesting. I wonder if I should actually... okay, let me think about it. Alright. String num representing a non-negative integer num and an integer k, return the smallest possible integer after removing k digits from num. Some constraints, right? K is going to be less than or equal to the length. Well, wait a second. Consists only of digits not having any leading zeros except for the zero itself. If k is equal to the num length, what about this test case? Yeah, what about this test case here? Output. Oh, really? Zero. Okay. So if you delete everything, it's just zero. Alright, fair enough. So the question is, smallest possible integer after removing these digits. 3 digits, 4, 3, 2, to form the new number, which is the smallest. So you can remove any digit and or any, what do they call that? You could remove any combination of digits, right? Because they're not really permutations, right? They're sort of each one is unique, I suppose. So each selection of digits, the order doesn't matter, right? If you pick index 0, 3, and 5, or 5, 3, and 0, however you do it, you're going to have the same result deleting, no matter what the order is that you delete these elements. So no matter what digits you remove, you're going to have n minus k digits left over. So you don't really have issues of like length you don't comparing the number of the size of the numbers, like the, I guess, power of 10 of that particular number, if that makes sense. So like 100. So you're always going to have some 4-digit integer left over after removing any possible selection of 3 digits from the number. And yeah, so from there, what that means then, I think, is to have the smallest of those possibilities means you basically want to optimize or minimize the leftmost digits. So you want the smallest possible digit that you can have on the left and then from there, so I guess so since 1 is smaller than all the is less than or equal to all the other digits, you'd want to have that 1 there. This is an interesting question. I actually don't know. How would you solve, like, so I don't know, I don't have a solution to this. I want to say this is probably a stack-based solution kind of a thing, using a stack, some kind of an optimization that you can do. So yeah, you'd want to have 1 because it's smaller than all the other digits, but 3 is less than 4, so you'd want to delete the 4, right? So that way 3 comes before 4. And in fact, you probably would even want to delete the 3 because 2 is less than 3 also. So you delete 3 too. And you want to keep 1. You would, something to note is you can't have leading zeros in the result, which is interesting. Oh, it doesn't matter. Actually, 0 counts as I guess optimal then, because 0 is better than everything else. Okay, so yeah, actually it doesn't matter. You would want to have zeros because a 0 in front basically just makes the number smaller, which is sort of not typical, but I guess that's something to keep in mind. So you kind of always do want the zeros in front. Removing all the digits is left with nothing. I guess that's kind of an edge case if n is equal to k. You just return 0. I don't know if that matters or not. I think yeah, we'll just say, yeah, it does kind of matter, actually. So, okay. So, what do? We delete 4 because 3 is smaller. We delete 3 because 2 is smaller. And we have another 2. And we have 1 more digit to delete. 1 is smaller, so you'd want to delete one of these 2's. However, you run out of digits at that point, and you have with 1, 2, 1, 9. I think that's, I want to say yes, stack is fine. You basically, the stack's empty, you push the element on the stack. The next element, if that's larger, you push that on the stack. The next element, if it's smaller, you pop the elements from the stack, and you decrement k. And if they're equal, I don't think it matters. I don't think you need to. It doesn't matter if they're equal. So you'd pop this minute. Yeah, I want to say that. That makes sense. Something like that, and then you could build afterwards. Does this work? We'll find out. I don't know if this is correct, but I have to think about like how to prove that this works. That this is correct. So we're gonna say for auto const auto c and num. And we're going to say if stack empty, then we just push this character C, and yeah, that's fine. And then otherwise, we say while stack is empty, it's not empty, and stack top is less than, no, it's greater than C, we're going to pop stack and decrement k. We're going to say k minus minus. Right, and do that, and then actually in all cases we push this at the end. So really this isn't a, If we're empty, that will return 0. Otherwise, we're going to return string in the string stream. Something like this. This is just stream. Been tinkering with string streams more and more lately. 9121 1. Oh, really? Is that right? One, push 1, 4, push 4, 3, you pop. Actually, it's kind of interesting. Can you pop back on strings? I think you can. Basic string, huh? Yeah, we can back, and can we pop back? Push back, pop back, yeah. Yeah. Yes, you can. Strings are versatile. Something like this. Let's see how we do. Okay. Oh, really? Huh. Yeah, in that case. It's kind of an edge case then. Let's just take a bunch of random test cases. Also, I don't think this is quite right. I have an invalid test case here. Wrong answer, huh? Oh, we were pretty close on the bottom two. That's interesting. Okay. Gotta remove all the leading zeros. Hmm. Pop the front. Hmm. quick while loop here. And we're gonna say substring index leading zeros, characters, number of characters is gonna be ret.size minus leading zeros. I think minus +1, -1, I don't recall. Yeah, it's a little confusing. It's if we're starting off at that index, then the number of characters is going to be, I don't know, let's say there's 5 characters and 2 leading zeros. So it's going to be start from index 2, and we want 3 characters, 5 minus 2. So it should actually be something like this. How does that look? Nope. Is that? That's not correct either. Well, how does that work? What? What is it? Containing position plus count. Yeah. What is this size? I'm a little confused here. Do we actually need the rest of this? I don't think we do. Oh, that's why. I think I understand. I think I see the problem. I think it's because this increments regardless of whether or not. That's why. That's okay. Interesting. I thought I did it correctly before. It's kind of neat. You also can just do. I don't think this really matters. I think the compiler would optimize this anyway, but we'll do this. All right, looks like it's correct for a few different cases. I think it says 11. How are we doing on time? 20 minutes? Wrong answer. Nice. Nice. Expected. 1, 2, 3, 4, 5. What? Zero and 0 at the end here. Excuse me? Is K not 1? Is K not 5? Why would this? Why would this one? These last two? 1, 2, 3, 4, 5. Whoa, what? Huh? What is going on? Why would that happen? Excuse me. I'm left wondering. Oh, that's why. Oh, I see the issue. Duh. Excuse me. Excuse me. I see the problem. Yeah, this was supposed to be an edge case, but if we modify K in here, then we can't. Can't use that, of course. Duh. Makes sense. Really kind of a subtle thing, but it's a good thing we tested more cases in case there was something I was missing. Yeah, I don't know, man. Wrong answer, okay. All the way at the bottom. Interesting. One, two, 1, 2, 3, 4. The last 4 seem to be 1, 2, 3, 4. Yeah, I'm just thinking about different kind of possibilities here, I guess. Yeah. Alrighty. So these are wrong. These are wrong. Also, I don't know how easy it is to hear me. Let me bump my volume up a little bit higher. I feel like I'm talking kind of low today. I don't always talk this low. And how are we doing? 23 minutes? Okay. Alright, let's try the first one. 2, 3, 4, 5. Output 2, 3, 4, 5. Alright. Well, I guess what I want to say is get rid of those leading zeros. But we would actually start popping we would say while T, decrement T, and ret dot pop back. I think that's what you end up with. Nice. Nice. That's what I like to see. Really? Okay. Could actually make this K again if you wanted to. Because we're not going to use it. Not going to use it. Okay. Interesting question. Interesting approach here. So a few things. So we say, okay, we push onto our string, our stack, each character as we go, and we say, we compare that character to what's already in this string, and if that character is larger than what's in the string on the back of it, then we're going to pop all of those characters off. Those are going to represent characters that we removed, and then we're going to push this new character on. And so that's the sort of the smallest next element we can get up to that point. And we're going to keep doing that until we read all the characters. And then what we're left with, we might have zeros in front. So we're going to go ahead and remove all those leading zeros. Those count as being in the string, but they don't count as elements that we include in the string, but they don't count as elements that we actually represent when we return our string. So that's more of a cosmetic change. And the upshot to that, though, is you want to do that first because we might remove characters from the back. Now, what could happen is you still have characters to remove, but however, there isn't like a more optimal way to, like, in other words, you've removed all of the characters in between that would be suboptimal, and now all that's left is to just remove all the largest character. Now you basically have a sorted list of digits, and now you just remove the back characters until you've removed enough characters to satisfy the condition, which is what we do here at this third step. So you have one step to remove sort of superfluous digits, then you have another step to make a sort of a cosmetic change. And the reason why you want to do the cosmetic change before you do the last step of just removing all of the largest elements from the back until you've removed enough elements is because you could end up basically you could end up ending this loop where the set of characters is empty, in which case you would terminate early. It actually doesn't, I don't know if it really matters that much which one you do first. I'm not sure that it really matters, come to think of it. But yeah, so this will remove whatever characters that are left that still need to be removed. You have a sorted list of digits from left to right now, and yeah, you remove all the digits you need. So, and finally at the end, if your string is totally empty, in other words, you removed everything, then you return a 0. Otherwise, return the string. I think that satisfies pretty much everything. All cases. I'm not exactly sure how to prove that this is correct. Also, I don't know if I'd be able to come up with this faster than 30 minutes. Excuse me, during an interview, and also not being able to kind of run various random test cases. I don't really know. I probably would get wrecked by this problem, truth be told. Let me just try some things. I don't know. Feels like I should have. I don't know, different tricky test cases that I may have missed. I don't know, what does this look like? Cannot have leading zeros in the test case. Oh, okay. Fair enough. Let's see what happens here. It's various test cases. All right, let's go for it. Hey, sweet, 100%. Relatively good on memory. Not bad. Nice. All right, sweet. Hope that was enjoyable. Hope that was interesting. I maybe do want to consider like how I might want to think about like how to prove that this is correct. I don't know. I just had like a vague notion that this would be correct. It's kind of a greedy solution, greedy stack-based solution. I don't know. I'm gonna go though. Thank you for watching. Talk to you soon. Enjoy the rest of your day. Take care.